Hello students, today is going to be the third day in our session on mathematical tools in physics, and today we will focus on use of logarithms. Now this is certainly a new topic for you all. This is going to be something extremely useful when it comes to tedious calculations in physics. Now use of logarithms, use of log tables, this is something that we will be discussing today in our class. So let's begin with the basic definition of logarithm. Logarithm of a number with respect to a given base is the power to which the base must be raised to represent that number. I repeat once again, logarithm of a number with respect to a given base is the power to which the base must be raised to represent that number. Now I will be giving you an example. Suppose if I write down logarithm of a number, the number is 1000, with respect to a base, the base is 10, is the power to which the base must be raised in order to represent that number. So log of 1000 for base 10 is equal to 3. Now you might be a bit confused as to how I have obtained this result. Why log of 1000 for base 10 is equal to 3? Now just go through the definition and then relate it with the example. Logarithm of a number, log of 1000 with respect to a given base is 10, is the power to which the base must be raised. Now the power to which the base must be raised. What is the power base in this case? 10. What is the power to which it should be raised in order to represent 1000? Now 10 into 10 into 10. Isn't it equal to 1000? And 10 into 10 into 10. This means this is equal to 10 to the power 3. So 3 is the power to which the base 10 must be raised in order to represent 1000. So log of 1000 for base 10 is equal to 3. Now we can generalize this result for any number. Suppose I say let a number n is equal to a to the power x. Just relate it with 1000 equal to 10 to the power 3. In place of 1000 I have written n. In place of a it should be 10 and in place of x it is 3. Okay, so I'm just generalizing the result. So let's proceed with the next step. So let n is equal to a to the power x, then log of n for base a should be equal to x, isn't it? Now in a similar manner I can write down log of 1 for base a should be equal to 0, isn't it? Since a to the power 0 is equal to 1. So log of 1 for base a should be equal to 0, and similarly log of a for base a should be equal to 1. Now these are two results that you need to remember. Okay, so very quickly then, logarithm of a number is the power to which the base must be raised to represent that number. So using this example we have generalized. So log of n for base a is equal to x. This means that x power is the power to which the base a should be raised in order to represent the number n. So we have used this result to write down two important steps. Now I am simply writing down once again how I have obtained this one. Now you must be knowing this, that a raised to the power 1 is equal to a, isn't it? So obviously log of a, to what power a must be raised? If the base is a, to what power the base a must be raised in order to represent this number? Obviously, it should be raised to the power 1. That's why log AA is equal to 1. So similarly, you can write down, isn't it? So in this manner we can generalize. Okay. Now there are some standard formula of logarithm. Actually, these are 4 in number. The first one is called the product formula. The product formula is written as log of m into n for base a is equal to now you will be surprised to see that a product changes into simple addition, simple summation, log of m to the power base a plus log of n to the base a. The next one, it is called the quotient formula. So log of m by n should be equal to we are dividing the two terms m by n and then taking its log, so that turns out to be equal to log of m minus log of n. The third one, it is called the power formula. Log of m raised to the power n for base a is equal to n times log of m. So the power comes as a product. This is the power formula. And last of all, if we want to change the base, then base change formula. Log of m for base a. Now we want to change the base a. We want to change it to base b. Then we need to multiply with this term. Okay. So these are the 4 basic formulas. The first one being the product formula, the second one being the quotient formula, the third being the power formula, and the fourth being the base change formula. Now these 4 standard formula in logarithm would be used widely while we are solving some problems. Now you might be wondering that what are those problems that we would be solving using these formula. Obviously these problems won't be regular mathematical problems, because up till now, up till class 10th, you have never used logarithms and you have quite conveniently solved so many mathematical questions. But obviously there are few problems where it becomes so important, extremely important, for us to use log tables, make use of logarithms. Only then we are able to solve or get accurate answers to these problems. Instead of doing any sort of approximation, if we want to make some accurate calculations, then we have to make use of logarithms. Now I would like to tell you that there are two systems of logarithms. Okay, the first one is the Neperian log. It is sometimes also called the natural log. And the second one is called the common logarithm, that is having a base 10. Neperian log has a base e and common logarithm has a base 10. This is the base. So Neperian log or natural logarithm has base e, common logarithm has base 10. Now, what is Neperian log? Neperian log, the base e is equal to 1 plus 1 by 1 factorial. I hope you remember the factorial part. 1 by 2 factorial plus 1 by 3 factorial and so on. And when we do this calculation, it comes out to be equal to 2.718 approximately. So in all theoretical calculations, we make use of natural logarithms. Now coming to the second one, that is the common logarithms. Here the base is 10. And in all numerical calculations, we use common logarithms. Now one main question, how to convert natural log to common log. How to do this conversion? So I hope you remember the base change formula. We will be making use of the base change. I want to change from base e to base 10, and for this I have to multiply it with this value, isn't it? Now log of 10 will be equal to 2.3026 times log, and this is equal to 2.3026 into 1. Log 10 is equal to 1. Therefore log of, we have to simply multiply with this number. So the conversion factor is this. So whenever we are doing any conversion from natural logarithm to common logarithm, we have to multiply it with 2.3026. Now up till now we have been discussing the basic rules, the basic formula. But now we will get into the actual part as to how to read the log tables. Now you might be wondering, how does a log table look like? Now in most of the standard textbooks of mathematics, lab manuals or the textbooks of science, you will be finding these log tables at the end of your textbook. Mostly it is given in the end of the textbook, and you will be finding so many numbers, a huge chart filled with numbers, and you might be wondering how to make use of these tables. Let me show you how these tables actually look like. So this is the standard logarithm chart. You can see the values. Let me zoom it a little bit so you can see the values. It begins from 10 and it proceeds. It doesn't end at 49 actually. It proceeds up till greater values, but it is one page of the log table. And there are different columns beginning with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. and in the end you are having one more column that begins from 1 to 9. The last column actually that begins from 1, this that I have zoomed, this part is called the mean difference, and then the general values. So this is how a basic logarithm table looks like. Okay, these tables are the standard tables that are available to us for calculations, and these are usually 4-digit tables. So the logarithm of any number can be read from these tables. Now before you actually understand how to read these tables, let us get into the theoretical part a little bit. The logarithm of any number consists of two parts. Logarithm of any number consists of two parts. The first one is the integral part, and that is called the characteristic, and the second part is the decimal part called the mantissa. So logarithm of any given number consists of two parts. The first is the integral part called the characteristic, and the second is the decimal part called the mantissa. Now beginning with the first part, that is the characteristic. Now this may be positive, negative, or 0. Now there are some set rules for understanding how to find out the characteristic. So for that, let me show you the rule chart. So there are two rules for finding out the characteristic. Rule 1. If the given number is greater than 1, characteristic is positive. Count the number of digits to the left of the decimal point. Subtract 1 from this number. This is the characteristic of log of the given number. Now you just consider the example for this number. You are asked to write down the characteristic of 1795.2. Okay, 1795.2. Now you just go through the rules. Count the number of digits to the left of the decimal point. Now how many digits are there to the left of the decimal point? 1795. Obviously there are 4 digits. 1795. So there are 4 digits. Subtract 1 from this number. So you have counted 4 digits, subtract 1. So 4 minus 1, that is equal to 3. So the characteristic for 1795, if you are writing down the logarithm of this number, then the characteristic will be 3. Similarly, you are asked to write down the characteristic for log of 16.78. So how many digits are there to the left of decimal point? 1, 6. So there are 2 digits. So from 2 you have to subtract 1. So 2 minus 1 is equal to 1. Similarly, if the given number is 1.923, to the left of the decimal point there is only one digit, that is 1. Subtract 1 from it, so 1 minus 1, so characteristic becomes 0. Now rule 2. If the given number is less than 1, its characteristic is negative. It is put under the bar. Count the number of zeros immediately after the decimal point. Add 1 to this number. It gives us the characteristic of the log of the given number. Now it is not necessary that always the number given to you for finding logarithm should be more than 1. It might be less than 1. Just consider the example 0.7821. In this case, obviously Taking a look into the number, you can ensure that it is less than 1, and then you have to count the number of digits on the right hand side of the decimal point. How many? Count the number of zeros immediately after the decimal point. You have to count the number of zeros. So does any zero exist in the first number 0.7821 after the decimal point? Obviously not. After the decimal point there is 7. So there are no zeros. So you can see there are no zeros. You have to add a 1 to this number. So 0 plus 1, that gives you 1, and then you have to put a bar sign. We don't put a negative sign, we don't put a minus sign, we write it as 1 bar. Similarly, the second number 0.0618. Count the number of zeros on the after the decimal point. There is 1 0, so it is written 1. You have to add 1 to it, so 1 plus 1 makes it 2, and then you have to put a bar sign, so it gives you 2 bar. Similarly, for 0.000345, how many zeros are there after the decimal point? 1, 2, 3. So 3 zeros, add 1 to it, 3 plus 1, that gives you 4, so 4 bar. So characteristic for the log of 0.000345 is 4 bar. So in this manner, using these two simple rules, we can find out the characteristic. If the given number is positive, it is more than 1 or less than 1.